Okay, so now I want to take a second. I want to talk about equilibrium. And so far in this course, we've identified at least two different types of equilibrium. One is the equilibrium that we get over here. This is the equilibrium in aggregate expenditure, what we call the demand side equilibrium. Okay, and then the next is what we're going to talk about in a second, which is the, I guess, actual equilibrium, the real ADAS, aggregate demand, aggregate supply equilibrium. It's kind of the one that really matters. What's the difference and why are there two equilibrium concepts? So this equilibrium over here, pointing is not helpful. You can't see what I'm pointing at. This equilibrium over here basically gives you a condition for aggregate expenditure equaling output equaling national income, basically making sure that the economy makes logical sense, that everything that's being produced is getting consumed, and that essentially that if something's getting consumed and being paid for, that payment is going towards consumption. It's like essentially an accounting truism that what you pay for something becomes a profit for someone else. Okay, so that's what this side is monitoring. The idea that if I give you $5, someone is making $5. So if I pay $5 for consumption, someone's making $5 in income or rent or whatever. Okay, that's what this is. Okay, and we use this to say that, let's say prices increased, consumption decreased, therefore we're able to plot a level of output for that price level. And if prices then decreased, we had an output for that price level. And if price went to $15, we had an output for that price level. And what that allowed us to do is come up with this fancy little demand curve. Okay. So from the aggregate expenditure equilibrium, what we call the demand side equilibrium, my cat is on my back right now. Please stop it, buddy. From the demand side equilibrium, we were able to plot a demand curve that specified a price level for every, specified an output level for every price based on where these two curves intersected. Okay. So as the price increases, come on, why is it not moving? As the price increases, this line decreases, and the output decreases. As price decreases, this line increases, and output increases. Okay, so that's what's happening here. That's that negative relationship for demand. Okay, so this is our demand curve. Okay. Then we had supply that we just introduced, driven by per unit profit. Okay, and that's basically a function of the input costs and the per unit price. Okay, so that was a little more straightforward. That was the equation we came up with over here. Okay, so it's determined by technology, the amount of goods per labor hour you can make, or goods per input you can make. Okay, the input costs, we define one input, so wages, over here. So as wages go up, profits per quantity go down. As productivity goes up or technology goes up, your profits per quantity go up. And as price goes up, profits per quantity go up. So just like the shifters, if we look back for a second, they're basically determined right here. Like everything you need to know about shifters is right here. Okay, so technology improves. That means A goes up. If A goes up, then this whole term goes down. If this term goes down, then profits per quantity go down. And my cat is back on my back. If there's more labor and capital, it's actually not profits per quantity going up, but overall, the overall market. So I guess number 4 is the one exception. But the other two are up here are basically if this goes up or down. Okay, and you can substitute wage with the cost of capital, so that would be essentially the interest rate, which is your cost of capital. So if you want to do R for interest rate, that's fine too. Or if you want to have minus R divided by, say, the productivity of capital, you can do it like that. But at any rate, the bare relationship is that profits per quantity increases if price increases, if wage decreases, or your input costs decrease, I should say, or if technology increases, or productivity as a whole increases. Okay, or if there's just more quantity to go around because there's more inputs. Sorry, go back here. So the supply curve is a little more straightforward than demand curve in that it doesn't have like 50 different components going into it. It's really just your input costs and your productivity. So that's your supply curve, and that's where the upward sloping relationship comes from. Again, demand can be extracted like 50 different ways through consumption and investments, government expenditure, exports, imports, and all the factors that interplay with them. Supply is really just the cost of wages, the cost of capital, the cost of land, technology improvements, etc. Not as much. So given that we know the supply curve, given that we know the demand curve, okay, we can just plot them together, and where they intersect is going to be your stable price level and stable level of output. Okay, so I'm not actually going to draw because we have it over here. Over here. Okay, so that's your equilibrium. Okay, if your price level were down here, okay, what that's saying is you demand this many units. Okay, this is what consumers want to buy. This is what suppliers actually want to sell. So there's so much unwanted demand or unfulfilled demand here. What's going to happen is suppliers are going to ask, hey, we'll supply you, but you got to kind of meet us halfway. You got to meet us at a higher price. Okay, so some of those people who demand will say, yeah, for sure. Okay, some of those people who demand won't end up doing that, and that's where you're going to end up here. So this is the people who demand willing to pay what they're willing to pay, and meeting someone who wants to supply them. Okay, and then vice versa. If you're up here, the price is too high. There's going to be a lot of people who want to supply, not as many people who want to demand. And the people who want to demand are going to say, hey, or I should say consumers are going to say, hey, there's more of us that really want to buy. It's just your prices are too high. If you knock down your prices, some of us will join and consume. Okay, so the people who are like highest willingness to pay are going to end up consuming up until they meet the people who are willing to pay, or willing to supply. Okay, so that's when you hit an equilibrium. So once you hit here, okay, maybe not everybody who was willing to supply is being met here, right? Like there's a drop off of people willing to supply from here to here. But if those people over here continue supplying, they're essentially supplying at a loss. Okay. So some of them will want to supply, but not all of them. and that's going to be met here. Okay, and this is essentially the price where the number of suppliers, the number of people who want to consume, and the things that they want to consume match the number of people who want to supply and the things that they want to supply. So that's your equilibrium point where the economy kind of finds its stable position, where the quantity supplied equals your quantity demanded, and there's a stable price. Okay. If it's not in equilibrium, you're either supplying too much or demanding too much. Okay. I'm now surrounded on all sides by cats. I got to be very careful in my movements so that I don't run them over. So anyway, the difference I want to once again highlight is that your aggregate expenditure model can be used to develop your demand side equilibrium, which will inform how you draw your demand curve. So it gives you what your price level changes will be for every demand curve, for every quantity demanded, which will then allow you to generate a relationship between price and quantity demanded, which you'll then use to ultimately get to your aggregate demand, aggregate supply equilibrium, which is the equilibrium that really matters in the economy, which is the stable price point for demand and supply, and will specify one quantity that is equal to quantity demanded and quantity supplied. So it gives you an equilibrium quantity, so an equilibrium GDP for an equilibrium price level. So 106,000 as it's drawn here, okay, versus a equilibrium that will shift for every price level, which is your demand side only equilibrium. All right, so that is equilibrium, and I know that I've kind of touched on it a little bit in depth before, but it's an important concept, so it's worth going over. And if you have questions on this, please let me know, okay, because it is an important concept.